Hey folks, very good evening and thank you for joining in today. Could you please confirm in the chat window if the audio and video are clear? So in case there is any glitch, do let me know and we'll fix it as soon as possible. So yeah, I can see myself in the window. I don't see any glitches. I can hear my audio back in the feedback loop. Cool. Good. Hey, thank you for confirmation, everyone. So we'll get started in a couple of minutes. Since it's 6:57, we'll wait for 3 more minutes for everyone to join in, and we'll start the session at 7 p.m. sharp. Again, as usual, we cover, like, I've made some notes which I'll discuss. Don't worry about the notes. Don't worry about taking the notes. I will share the whole notes in PDF form at the end of the discussion, and I'll place it in the description section of this video after the session is over. So don't worry about taking notes. We want you to understand the concepts and participate actively in the interactive parts of the discussion. So once we cover all of the notes and all of the concepts that we want to cover, we will spend some time on Q&A. So we'll spend ample time on Q&A, so don't worry about it. We typically spend easily at least half an hour on Q&A. We'll try and answer as many questions as possible. And yeah, so that's the agenda, or that's the plan for today. And since we have 2 to 3 minutes, I can answer a few questions. Okay, cool. So this is a question from Nitin, who says, I'm a 2015 pass out and have 2 years experience in TCS and 3 years in SBI. Can I do a career transition now to machine learning? What are my chances? So Nitin, I believe over the last 5 years post your graduation, you would have learned some programming or have some experience in software engineering or related field at TCS, and certainly you would have learned some domain knowledge in banking itself. So some of the types of companies, yes, so of course you will have to learn all of the machine learning, deep learning concepts. You will have to refresh programming knowledge, probably something that you have forgotten in the last 3 years. But it is possible for you to transition into machine learning and data science roles by building on top of your domain expertise in banking, your prior 2 years experience at TCS, and trying to get into data science and machine learning roles at companies which are either banks directly. For example, we have HDFC, which is setting up a data science team in India. We have Wells Fargo, which already has a data science and machine learning division in India. So you can join some of these banking and financial services companies, or you can work for companies that build software for these. So that is something that you can certainly do. So cool. Anchal, I'm very happy that you're making progress. Good to know that. Always it's good to hear students making the most out of the course and succeeding, and the course helping you and the whole team helping you. It's always a great moment for us. So can you speak about how India compares with in AI with respect to US, China? Again, it all depends on what context you are looking at. If you're looking at it from a cutting edge research perspective, obviously US and China and Chinese nationals in the US are some of the biggest contributors to the most cutting edge AI techniques. If you're looking at corporations and universities, some of the best universities and companies with research labs are mostly in the US, some of them also in China. So if you're looking at the bleeding edge of research, certainly it is Chinese nationals in the US, certainly some Chinese nationals in China itself and US are the biggest places. But if you're looking at career opportunities, because India has a very large pool of English-speaking, technically educated population. So if you're looking at careers, right? So India is certainly very good. So the number of machine learning and data science roles in India is surely growing almost as fast, if not more, than China. And that's because of 2 reasons. We have a very successful and thriving services ecosystem with large companies, internationally large, like TCS, Infosys, all these companies, which are building world-class AI and machine learning technologies for their clients across the world, not just in India. Similarly, we also have very interesting startup ecosystem ourselves, and we have giant American corporations which have centers in India. Like you take Amazon, you take Google, all these companies have research and development divisions in India. So in terms of a job market, I think India is pretty much out there, almost competing with US and China. But in terms of research, we are slightly behind for sure. Cool. So Jasmeet has an interesting question. So let me answer this question, the last one, before we start the session itself. This is something very close to what we do. So Jasmeet says, how does data science and machine learning, how is it leveraged at tech companies? There are 3-4 things where it can be leveraged. For example, first and foremost, we use it ourselves because we are sitting on literally a few lakh questions that we have already answered in the last few years in various courses that we offer. Whenever a new student asks a question, we run an NLP engine. We have live sessions on those topics also. So we run an NLP engine to get all the similar questions that we have already answered in the past so that our mentors can answer these questions faster. Very simple, very simple thing that we do. Similarly, we have built an online examination platform because we are starting these diploma program with University of Hyderabad, where we use face recognition and also face tracking technologies using computer vision and deep learning algorithms to track if somebody is cheating in the examinations. These are two very simple stuff that we have already built and we have already used, right? Similarly, I'm sure there is a lot of scope in EdTech, whether it is building smart learning platforms, all of that is very much there. Okay, cool. So Sharma has a question. I'll answer this and then we'll jump in. Should I attend the session because I did not watch the earlier 2 live recorded sessions? Sudeep, don't worry about it. His name is Sudeep Sharma, I believe. Don't worry about it. We'll discuss strategies and less of code because the code is covered in the other 2 live sessions. The strategies you'll be able to understand and participate, right? Okay, folks, let me just start sharing the screen right away. Give me a second, please. Okay. Okay, so can you please confirm if my screen is visible to you? Again, I have the chat window on my computer. So could you please confirm if the whole screen is clearly visible and if I am audible or not, so that we can get started with today's session. Could you please confirm in the chat window? Okay, cool. Okay, folks, so the agenda for those of you who have just joined in the last few minutes is as follows. We'll cover these notes. It might take us anywhere from 60 to 90 minutes. And within this session itself, I'll ask you some questions and you can participate in the interactive discussion via the chat window. Right? Once we finish this, we will spend approximately 30 minutes in answering general question and answers. Right? Again, since this is a public session, it's almost impossible to answer every question in 30 minutes. We understand that. Anything we cannot answer, you can always email us or reach out to us via our email address that we have at appliedaicourse.com. Right? So let's get started here. So this session is all about how do you acquire data? How do you get high quality data for various machine learning tasks, whether they are NLP tasks, whether they are computer vision tasks? How do you acquire this data in a smart fashion? Again, I have intentionally put smart in quotes because this smart can be thought of in 2 ways. We'll discuss some techniques where we'll use machine learning and deep learning to acquire data smartly. Again, even if you're not an expert in machine learning, deep learning, you'll be able to understand the general idea itself. Similarly, more importantly, we'll discuss about some very smart hacks or strategies that we will employ on using internet resources, whether it is search engines, whether it's e-commerce websites, to acquire some very interesting high quality data ourselves for various machine learning and AI techniques. Again, this whole session itself will be like many of our other components. We will take real world examples. Some of these examples that we're taking are problems that some of our students have solved as part of their exercise problems or as part of their assignments or as part of their self-case studies. Some of them are questions asked by our students via email, etc. Right? So we'll actually discuss real problems and look at what strategies or hacks and what techniques we can employ to get high quality data. Now, so as far as code is concerned, most of the strategies we will use revolve around 2 things. One is using a web scraper to scrape whatever data we want, and we'll discuss about that in detail. So if you do not know how a web scraper works, we have a live session. Again, I'll provide the PDF link of this whole document in the description section of the video, at the end of the session. So don't worry about taking notes. We will provide you that notes. So you can watch this video. Again, I have time-stamped it because this live session is a 2-hour live session where the first part talks about how to write code effectively and the second part talks about how to build a web scraper. So there are 2 parts in this. So I've given you a time-stamped video link where you can watch how to build a web scraper in Python using very nice tools. Simple web scraper, nothing very fancy, simple web scraper using Beautiful Soup, very popular library to extract information from web pages. Similarly, we have another again, both these live sessions are publicly available. So the second strategy that we'll use is we'll use web APIs. Again, in this live session, we discussed about how to use Bing search API and things like that, right? So I'll also provide a link to that. So as far as the code to implement many of these strategies and hacks are concerned, all the detailed code is already covered here, right? So we will focus more on the strategies and hacks. As far as implementation is concerned, it is basically taking the code that we have in these 2 examples and modifying it slightly. Okay, cool. So again, some of you may not have watched these live sessions. It's okay. Try to understand the strategies and hacks so that as and when you come into a real world situation where we have to do it, you can follow the steps discussed in these live sessions and implement these strategies and hacks in code based on the code that we describe in these 2 sessions. Cool. So, okay, so let's start with the first problem. Okay, this is a problem that many of our students have asked us, and this is a problem that I have personally worked on when I worked at a large e-commerce company in the past. So the problem here is you want to extract something called as aspects for each product. Now, so the problem here is, given some real products, for example, let's take an example, right? Imagine you have headphones. Again, on most e-commerce websites, headphones at one point of time were one of the most sold product category, right? Because everybody, whether you're a smartphone user. Sorry, is there a problem with the display? Let me just check. Display not visible because of darkness. 1 second, let me just check that. Is there a problem with the display? It is clear, right? I'm able to see the display. The display is blurred. Can you increase the quality of the video? For example, try to watch it at least 480p so that you'll be able to see it. So it's good, right? Yeah. Okay, it's all right. Okay. I was just looking at the chat window, so everything is looking good. Okay, we'll continue. Sorry for the trouble, folks. Okay, let me again, if there is any issue, I'm looking at the chat window. In case there is any problem that a lot of students are raising, I'm keeping an eye on that. Okay, all good with display. Okay, sure. So if something looks blurred, just increase the quality. Again, since this is mostly text, even on 4G, you should be able to watch this fairly clearly. Cool. So, okay, let's take the real world problem. So take a product category on an e-commerce website like headphones. Now for this headphones, there is something called as various aspects related to headphones. For example, you might want to buy a headphone with a mic, or you might want to buy a headphone with noise cancelling, or you might want to buy a cheap headphone. Sometimes you want to buy a headphone under 1,000 rupees, right? So under 1,000 rupees, or you want to buy a headphone for your kids, or you want to buy a wireless headphone, or you want to buy a gaming headphone. So you can think of all of these as various aspects or facets. Okay, there is another term that is often used called facets. So you can think of each of these, again, within the natural language processing community, the technical term used is aspects of a product. They're also sometimes called as facets of a product. These are all various factors, if you think about it, that users decide which product to buy based on these aspects. Okay. Now the challenge here is, imagine you're at an e-commerce company, right? Or you're building a website to help people purchase products on e-commerce websites. Now the challenge that you have here is, imagine there is a broad category like headphones, right? Again, when you are purchasing a headphone for yourself, you would say, hey, I want to buy a gaming headphone if you're a gamer. Or you might want to buy a wireless headphone, or you want to buy a headphone with a mic. So the challenge here is, for this product category called headphones, how do you extract all of these aspects automatically? That is a challenge. Imagine nobody gave you this data. Nobody said, hey, for headphones, these are the aspects that are most important. Nobody gave you the data. Now, given just this keyword, which is headphones as a category, can you extract all of them? Similarly, for example, if you're trying to build, let's say, let's take a laptop, right? Something, or a smartphone. Even a laptop will have lot of properties, right? Or lot of aspects associated with it. Do you want a student laptop? Do you want a gaming laptop? So for almost for every major product category in e-commerce and also in physical commerce, like physical stores, there are these aspects. So how do you extract this information automatically? Let's say you do not have any information. Or imagine you could be a small startup also. You need not be a e-commerce giant. You could be a small startup building a e-commerce solution where you want this. Or you might be working at a services company building a product for, let's say, Target or Walmart or DMart, right? All these, or Reliance Digital, right? Suppose you're building a solution where you want to extract this. It's a very common problem in both online and offline retail. Now you might say, hey, why are these aspects helpful? So one way that, again, these aspects are used in many aspects. One of the simplest aspects you will see is in the filters. For example, these are the filters that you see. So if you go to Amazon.in, so let me just show you that. Just let me go to Amazon.in and show you that. Amazon.in. Right, so you can go and search for what is happening here. Okay, so you search for headphones. So look at this. Within headphones, you have in-ear headphones, on-ear headphones. Then you have these various pricing points. You have the top brands that people are purchasing it from. You have with these aspects like with microphone, without microphone, wired, wireless, Bluetooth, USB, infrared. Again, some of the top features that people are looking at, like noise cancellation, sports, volume control, microphone. Look at this. So all these are called as search filters, right? So one of the applications, not the only application, but one of the applications is to automatically generate these search filters for each product category. Like for example, whether it's a wired or wireless, whether it has a microphone or not, right? All these, can you automatically extract this? Because imagine if you're working at Amazon search or Flipkart search, you would want to do this, right? So, or if you're building any search engine for an e-commerce company or even a physical retail company like DMart or Reliance Stores or Walmart or Target, any of these companies, right? So how do you, so one of the applications of extracting aspects is to automate search filters. Another aspect is this. Suppose if you might have seen this, right? On Amazon itself. Let me show you this example again. Suppose if I go and click on this, right? So this is a product. It has a bunch of ratings, all that stuff. Now, if you go down here, you have this very nice list of reviews. So look at this. The sound quality is very important. Noise cancellation, right? So all these keywords, can you automatically generate? Again, to generate, so if you want to read reviews that mention about noise cancellation, you have to know that noise cancellation is an important facet or factor. Similarly, here are some interesting features that people are looking at, right? So if you can extract aspects, right, it can be used in search, it can be used in the reviews part. Similarly, there is a whole area in natural language processing called ABSA, aspect-based sentiment analysis. So what aspect-based sentiment analysis does is, suppose if you have, let's say, a Bose headphone, okay? Again, if you have a Bose headphone, now you might have lot of reviews, right? You have lot of reviews related to it, user-generated content, right? You also have some text or product description. Okay, you will also have some product description given by Bose itself. You have all the data. Now, by mining all this text data, aspect-based sentiment analysis basically says, can you find out what all aspects are there and for what aspects do people are highly positive about it and highly negative about it. So for a Bose headphone, people might really love its noise cancellation and people may not like its high price, right? So extracting aspects is a very, very important problem for multiple reasons in most e-commerce websites. Now the question that we have here is this. This is the task. So I hope you are convinced that extracting aspects is a good problem. So the question here is, given a product category, let's say for example, okay, let me take an example here. So let me take an example. Suppose the product category is headphones. Let's stick with this simple example. Okay, again, headphones is a very popular category on most e-commerce websites. So suppose you have a category called headphones. How do you obtain aspects easily? Okay, so I'll open up the chat window and I'll see some suggestions that you give. Please put in your suggestions. Let's take 2 to 3 minutes. Please think of some strategies. The problem definition, I hope, is clear. You're just given a product category like a headphone or like a laptop or a smartphone. How can you extract these aspects? Imagine you're working at an e-commerce company. Suppose imagine you're working at some Amazon or Flipkart, right? So let's assume you're working at this e-commerce company. You have all the data accessible to you. How do you do it? This is a simpler case. Imagine if you're not working at these companies, how do you do it is a trickier thing. Okay, so I'll write the solutions that everyone is suggesting. Tulio is suggesting an interesting strategy. Tulio is suggesting that he will perform NLP on user comments. Okay, so on user comments. Okay, so that's what Tulio is suggesting. We have okay. So others are suggesting specific techniques, like within NLP, they are saying we will use named entity recognition, etc. Others are also suggesting that we will obtain this data, the user comment data, by using a web scraper. All these are valid solutions. Okay, so another very interesting suggestion. I really like this. So others are suggesting, okay, cool. So user reviews also. So this is one broad approach that everyone is suggesting. The other approach, which I really love, is people are suggesting, I think this is from a couple of, couple of you, only couple of you are suggesting that we will also use the search history. This is a very interesting strategy, right? So they're saying we will use the search history to extract it. Can you please elaborate how you will use search history? Okay, others are also saying, in addition to user comments, they will also use user questions and answers. Very nice. Okay, so again, you have a lot of text data related to a product, right? Whether it's user comments, whether it's question and answers, or product description, right? Whether it's product description. So people are saying they'll use all this data, they'll run some NLP algorithms on it to extract it. Okay, so based on user reviews, based on ratings, but our objective is to get the aspects, right, for each product. So broadly speaking, there are two strategies that I see here, broadly speaking. Now, most of you have suggested this. I think only 2 or 3 of you have suggested this approach. Okay, I get it. Okay, cool. So we'll explore both approaches, and I will try to convince you how to build a solution using this approach, whether you're working at an e-commerce company or whether you're outside an e-commerce company. Okay, so let's so good, very interesting. Thank you for your suggestions, folks. So one idea which I've written here is, you take all of the user given content, right? Whether it is user given reviews, whether it's user given question and answers, whether it's a product description, whether it's text data, you'll build a natural language processing model. Most likely nowadays people use transformer based models, whether it is BERT, whether it's a full-fledged transformer or a GPT based model. These are the models that are used for aspect based sentiment analysis or for aspect extraction today. But all these models require lots of training data. The biggest problem in this is you need tons of training, you need lots of training data. You need tons of training data to be able to build actual machine learning or NLP models for this reliably across the thousands of product categories. That is your biggest problem here. Well, I'm not saying it's impossible. I know some companies which do this, but you require a lot of training data. Now, obtaining this training data is the tricky part. So the alternative is there a hacky way to obtain these aspects data easily? Some of you have suggested that you will use the search history. Now the problem here is this. With search history, there are two approaches. Suppose imagine, okay, so here is an interesting thought process. Suppose imagine you're working at, let's say, suppose you're an employee at an e-commerce company, right? Suppose you're an employee at e-commerce company, getting access to the search history is trivial. Like I worked at this subsidiary of Amazon called A9. A9 stands for algorithms. It is a part of Amazon which works on search and advertising. So all of Amazon search and some aspects of Amazon advertising is built by this team called A9. So I've had access to actual search history and search data at Amazon itself, right? So if you're working at this organization like A9, which is nothing but Amazon search, great. What if you're an outsider? What if you're an outsider? Suppose imagine I'm a small startup which wants to extract, or I work for a services company, or I'm a small e-commerce company and I'm an outsider. I don't have access to the search history. Like Amazon has hundreds of millions of people searching every day. If I'm an outsider, if I'm outside this e-commerce giant, how do I obtain this data? So let's focus on this aspect now, because very often you may not have all the access that somebody at an e-commerce giant might have. So here the idea here is, can we hack our way around? Any suggestions here? I hope this is clear, right? Can you suggest, just the way you suggested some ideas, again, I hope the problem is clear, right? So the problem here is, as an outsider who do not have access to the search history, because some of you suggested search history. The problem with search history is, if you're outsider, you are like, I'm right now not part of Amazon, right? So how do you do it? So some of you are suggesting that we use web scraping, all of that, right? Yes, that's a valid solution, no doubt. I just discussed that a couple of minutes back. You can scrape all of this. There are two ways to do it. You can either scrape it, or Amazon also has, at least some e-commerce companies also provide web APIs to extract this data in a proper API based mechanism. Whenever you have APIs, please use them. Or you can build a simple web scraper and scrape it. But the problem, as I described, is to train this NLP model, you need tons of labeled data, which you may not have. So the problem in going through the NLP based, scraping based model is you don't have data. The problem in using the search history data, is, if you're an outsider, how do you tackle this problem? Yes, there is an Amazon product API for this. Yes. So, okay. So, I think, I don't know what's his actual name. The alias is CNH007. He says if Amazon sees a lot of traffic, they will block your scraper. Yes. So, we have described in our other live session. So, in this live session, we describe about how to ensure that the web scraper doesn't break the rules, how to ask it slowly. Similarly, even when you are using web APIs, there will be rate limiters. You cannot call the API more than 10 times in a minute or so. Then what do? You run the code for hours together. So for one of our case studies, we used Amazon Product Search API and we ran the code, I think, for 7 to 10 days, because they would say, hey, you can't call more than so many APIs every hour, every day. So we said, okay, we'll call these API data very slowly. We built an Amazon fashion recommendation system by actually fetching the data using the Amazon web search, Amazon product APIs. Slowly, it takes 7 to 10 days to acquire the data, but that's okay. We got a few 100,000 details about a few 100,000 products on Amazon. You have to be patient. There are no shortcuts here. Okay, so cool. So do we have some pre-trained model that can be used? This is from Sai Sushant. Yeah, so what sort of pre-trained model will you use here? Ask feedback from people who bought the products. Very few people actually give you data. So imagine if you want to do it today, how do you do it? So Himanshu says, if you search for headphones, we'll get different recommendations, like high noise cancellation, then high noise will be my aspect. Oh, so Himanshu, what you're suggesting here is this. So you'll search for, okay, so what you're suggesting here is that you'll search for headphones here. You'll get a bunch of headphones. You'll go to one of these headphones and then you'll scroll down and you're saying you'll scrape this information. So you're saying you'll scrape this information. Yes, that's one strategy that you can employ. Raghav says, can we use Bing Search API to get similar search results? Yes, you can. But I'll come to Bing Search API in just a few minutes. How does search history help? I will talk about it. Don't worry. I'll explain the solution. Those of you who suggested to use search history, I'll talk about the solution. Don't worry about it. Okay. So since I'm not hearing a lot now, let's tackle the solution, right? So the solution here is, can we come up with a strategy, a hacky solution, but a working solution to obtain aspects as an outsider? The tools that we have are, we can use APIs to extract data, or you can scrape some data, not too much data. Cool. So, okay, so let's go here. Okay. So most search engines are a go. So let me explain the solution, then we'll go to the interactive part little later. So most search engines, whether it is Bing, remember Amazon is also a search engine. In the US, the Amazon product search engine, more people search for products on Amazon than on Google. Okay. So it is very, very important. So any search engine, whether it is search on Google, whether it is search on Bing, whether it is search on Wikipedia, whether it is search on Quora, whether it is search on Stack Overflow, whether it is search on Amazon, there is goldmine sitting there. So from a search engine, there are 2-3 very easy things that you can get. For example, you can get the top search results. Again, in this live session, using web APIs in Python for machine learning, we actually teach you how to use the Bing API. Okay, we describe this. So if you're not sure how to use a Bing API, please check this, where we walk you step by step on how to use Bing Search API. Okay. And the process is same for most other APIs. You just have to understand the web API and call it from Python. Cool. The methodology is more or less the same. So remember that search engines are already working on the company's data. They are already sitting on a goldmine of data. Like for example, web search engines already scrape the whole internet. So their top search results is a goldmine of data. Instead of you crawling data from the internet, they already have done it, and they have already sorted it and arranged it by running billions of dollars worth of algorithms on it. Search engines also give you autocomplete. Don't forget this. This is an often overlooked feature of search engines. Search engines also gives you answers or related questions. I'll show you some of these examples in a while. Okay. So most important thing here is, a lot of people don't use various search functionalities on various websites. Okay. If you learn to use that, you can acquire tremendous amount of beautifully clean data for a lot of machine learning tasks. So the tool that we will use to solve our aspect extraction problem is autocomplete. Now, how is autocomplete designed? So on Amazon, or any search engine for that matter, you take Bing, you take Amazon. Since we are working on products, we will use Amazon because it's one of the largest product search engines in the world. So if you go see, how is autocomplete implemented? Autocomplete is implemented based on how frequently users have asked these queries. So this is based on human data. Again, the autocomplete is typically managed by the search team itself. While you may not have access to the whole search logs, like imagine if I'm outside Amazon, I don't have access to all of the Amazon search data, but I have access to autocomplete, which is a summary of lot of search data that they already, because this is on top, this is built on top of the search logs, right? Right, on top of the search data, this autocomplete is built. And here, based on frequency, whichever queries are more frequently asked, or which means which of the factors which are more important, that data is already there in autocomplete. Okay. So you can use, again, if you are using, let's say, Bing, again, you can do the same thing with Bing. For example, let me just show you the idea here. Okay. Both on Amazon and Bing. Okay. So let me just go here. So the moment we type headphones here, look at this. The autofill here, this is the most interesting part. Okay, so I can't do this. Okay, so I type headphones and I type space and I leave it. You have to wait for a second for the autofill to come up. In this autofill, you'll say wireless is a very, very important facet or aspect that people are searching for. And why is it at the top? Because most people are searching for that, right? People are also searching with mic, wireless, with mic, wired. Lot of people are searching for Sony headphones in India. Again, remember, this is Amazon.in. Lot of people are searching for headphones under 500 rupees, which means having a filter here which says under 500 rupees is very helpful. People are searching for gaming also, right? Similarly, if you think about it, see, look at this. This autofill is, or autocomplete is a phenomenal tool that we have. Unfortunately, Amazon doesn't give you an API to extract this. So you'll have to extract it using scraping. So the way you do it is, in scraping, you go to Amazon.com. Okay, so let me show you this. So you go to Amazon.com, in the search bar, again using your tool, right? In the search bar, you type headphones and you press a space, right? Again, all this we discuss how to do it in Beautiful Soup in our course videos, right? In the live session that I described. So you press headphones and then wait for a second. In your code, you have to add a delay of 1 second. Then this whole information will be filled. Once this information is filled, this information, all this data is there in the HTML file. You just have to extract it using Beautiful Soup. So again, it's very simple. You just have to go through the HTML code, understand the HTML code, find the XPaths. Again, all these details we discuss in the other live sessions. Find the XPaths and extract this information. This is a gold mine, right? But you have to be careful. Again, if you try to scrape this by throwing hundreds of search queries, Amazon will simply block you. Don't do that. Respect the privacy, respect the policies. Similarly, you can do the same thing on Bing also. But the best part with Bing, so the key idea here is, if you want to use Amazon, web scraping is a solution for which you'll use a library in Python called Beautiful Soup. But remember the policies, respect the robots.txt policy. Don't query hundreds of things in a second, right? So you could query, let's say 10 times a minute, 10 times per minute. Don't overdo it, do it slowly. Let your code run overnight. Like we have run this code, we have had students who have done case studies based on this data. We have run it respecting the robots.txt by running just a few times every minute. So if you want to extract this information from Amazon, web scraping and using Beautiful Soup like tools is the solution. If you want to use Bing search engine, the same thing also happens at Bing, by the way. Let me show you. So you can go to bing.com, and if I type, let's say headphones, my bad. Okay, headphones, look at this. So at least the Bing search data says headphones Bluetooth is what everybody is searching. Headphones with mic, headphones Amazon, a lot of people are searching. Headphones wired, headphones logo, headphones parts, headphones with wires. These are what people are searching on Bing itself. The good thing with Bing is Bing provides you a auto suggest API. Okay, so this is part of Azure. Again, so in our previous live session about using web APIs, we discussed about how to use Bing web search API. Bing auto suggest API is very similar to search API. The endpoint of the API is slightly different, except that it is very, very simple. Again, you can either use the API based approach or you can use the web scraping based approach. The key here is lot of information about the search data is there in autocomplete. Now, still the problem is not yet solved. So the way I would try to solve this problem, imagine if I were solving this problem, I would solve it as follows. Okay. First is I would type just headphones. So let's go to Amazon. I would type headphones. Again, it only gives you like top 10. So you get a ranked list. So this is the highest rank, rank 1, rank 2, rank 3, rank 4, rank 5. You get a ranked list. But by just having these 10 recommendations, it's not sufficient to extract all the aspects. Look at this. By just having these 10, I can't extract all the aspects. So what will I do here? I will type headphone space A and I will leave it there. I will simply leave it there. The moment I type A, it will give me all the things with A. For example, a lot of people are buying AirPods, which are Apple-based headphones. So there is also Apple. There is also Audio Technica, very popular company for high-end headphones. There is active noise cancellation. ANC means active noise cancellation with mic, right? Similarly, I'll search with B. I'll just leave it at B. I will not do anything. See, the moment I type B, Boat is a very popular Indian company that makes pretty affordable and pretty good, at least some of their models are very good, headphones and earphones, right? So that's something that a lot of people like, because you see boat repeating multiple times. You see boat here, you see boat here, you see boat, you see boat here, right? Similarly, I'll search with C. I will search with D. I will search with E. One thing you'll observe when I type F, remember for in English is called a preposition if I'm not wrong. So the moment I type F, you get for all these things. Look at this, which means a lot of people are searching headphones for this application, whether it is for kids. Girls probably want slightly glitzy headphones, slightly pinkish and slightly glitzy models. For PC, for gaming, for laptop, for kids who are girls stylish mobile phone. So F, so you try it for all the words, okay? EF. Similarly, if I type U, right, you try it for all the alphabets. Here you get under all these price points. These are the price points that people care about. Imagine if I am working at a headphone company and I have to decide what price point I should operate. This is a gold mine of data for me. These are the price points that people are searching for, right? So the strategy that I will employ, again, I'm not saying this is the only strategy. This is one of the possible strategies. You'll search headphones, you'll get a ranked list. I'll just call it L followed by underscore. Headphones space A. Imagine I get a list which is LA. So I get multiple lists like this. Again, there will be some overlap in these lists. There will be some products, or there will be some auto suggest or auto fills which will overlap between these also. But now I get a much larger list. I get a much larger pool of words that I can use to extract aspects. One of the simple ways to extract aspects is there is something called prepositions in English. Okay, so these are all the top 100 prepositions that people use. Now remember, I showed you this, right? The moment I typed headphones, let's say F, right? Again, for is a preposition. I can easily just try with these prepositions, and I can see that when I say for, these are all the aspects that people care about. Similarly, so let's look at some of the, again, not all prepositions may be relevant to every product. So for example, under is something that we saw. With, okay, so with is another preposition. With basically says all the other stuff which people care about, right? So you can use these prepositions to clean up this list. This list might contain a lot of stuff. You can use prepositions to clean up this list and get a smaller list of aspects. Okay, again, I'm not saying this is the perfect solution or the only solution, but this is one of the possible solutions, one of the smarter hacks or smarter strategies to use autocomplete to extract aspects, right? For example, if you actually run this whole thing, these are some of the most commonly occurring things that you'll see in a lot of lists. You'll see gaming, you will see mic a lot, you'll see boat, which is nothing but a brand. Sony is a brand. So if you have T, if you type T, right? So if you type T, okay, sorry. So if you my bad, just a second, done. My bad. Okay, this is my done. Okay, so if I type T here, type C, because a lot of smartphones today have type C, or they don't have a headphone jack. So type C is another very useful thing. So you get a good list of these aspects, and if required, you can manually review them and quickly post-process them. So once you get all these lists, you can use prepositions to filter them, and then you can also manually review them at the end, because you might get like what, 50-60 aspects. Just pick the most sensible ones. Again, you can also order them. You can also order them based on how frequently they are occurring. And remember, all these lists are ranked lists, which means for anything which is ranked higher is more popular in the search data. That's what it means, and that's what we should. So we can get these top aspects using prepositions and using this ranking that you have. This is one very simple strategy that works. Again, please understand that I'm not saying this is the only strategy. This is one of the strategies. Okay. So let's move on. Again, think of other strategies that you can think of. There is no limit to hacks and strategies that you can come up with. Here is another problem. Actually, one of our students emailed us this problem, I think a few days back. So he said that, Varma, we are building an app at my company, where there is some information that every employee or every customer has to fill. Now we want to determine whether what they fill in their name. So it seems they have first name and last name, right? So they have first name and last name, right? So this is a product that they're building for their Indian customers. Okay. What the customer wants is to make sure that the names that people are entering are valid names, right? I hope the question is clear, right? So this is actually a question that one of our students emailed us to say, hey, how do I solve this problem? I've tried some techniques, they're not working. How do I solve it? Okay, it's a very, very interesting problem. It sounds simple, but imagine you have a form where you have a first name and you have, let's say, last name or surname, right? Which you have to fill. The question here is, again, let's assume, again, the customer could be an Indian customer, the customer can be a European customer, the customer for whom you're building this could be African, right? They could come from any part of the world. How do you make sure that the name that is entered is valid or not? Can you suggest some strategies, folks, for this problem? Okay, so let's see your strategies. So Hemant has a question which is for computer vision related tasks. How do you acquire data? I'll come to that. But let's tackle this problem. Given a first name and a last name, how do you validate that the name is a valid name? Can you recommend some solutions here? Again, I'm looking at the chat window. Can you suggest some solutions, folks, for this? Again, think from a hacky mindset. Okay, interesting. Can we use regex to check name? Okay, so that's a good logical software engineering solution. So they're trying to use a regular expression to search if there are numbers in a name, right? So that's a good validation check. I believe somebody who suggested this worked in software testing. That is surely a valid thing. Names cannot have, okay, so you'll use regular expressions to ensure no numbers and all that, valid. But suppose if I enter a name like A, X, B, C, something like this, there are no numbers, but this is not a valid name. So, okay, so people are saying rule-based systems, no numbers, using social networks. So Amrit suggests that we'll use a social network. Can you recommend how will you do it? That's a good idea, but how do we do it? Verify with existing database. Okay, so you'll cross-check against a database. Suppose you don't have a database of those names. So no DB. You don't have a database, right? You're building this whole solution. You don't have a, can I use some verification? Others are suggesting that they will use a named entity recognition. This is what our student also recommended. There is a problem with it that I'll come to in a couple of minutes. Checking with a phone directory like Aadhaar. Nobody will give you access to Aadhaar database. Most governments are extremely protective not to share this information. So don't expect to get access to a government database like that. Can we use Twitter API? That's a good idea. That's an interesting idea. But Twitter aliases may not have the actual valid names. Semantic analysis, okay. Very interesting. So Omkar suggests that we will use Google search. Exactly. So let's see how to be smart about it. Others are also suggesting interesting strategies, which is they will use the BSNL phone directory. Again, it's been years I've seen the BSNL phone directory, but I'm sure if you can download it publicly from somewhere, that's also a very neat idea. Okay, cool. So let's look at one solution. I'm not saying this is the only solution. Some of you, one of the common solutions that a lot of students recommend is they'll say, hey, let's use the named entity recognition. But there's a problem with this. Most NER systems have been trained on European names like John, Smith, Adam, right? So they work very well for European sounding names. They do not work well for non-European names. Again, our student actually tried it on Indian names and African names. They don't work very well. They actually are terrible for so your named entity recognitions, most of these models, again, remember at the end of the day, an NER is based on an NLP model. This model is trained with names like this. So don't expect it to recognize names like Srikant or Chekuri, which is my surname. Don't expect it to recognize them, right? Because it doesn't have training data. So, but for you, collecting this database or training data is very, very expensive. So again, as some of you have suggested, we can use search engines here. So let's look at this, right? So again, this is from Microsoft Bing. My surname is Chekuri. So I just typed Chekuri surname. Okay, or you can type last name, right? The moment you do this, look at this. Look at the search results that you're getting. You're getting search results from Ancestry, which tracks people's ancestry. Similarly, you're getting from websites like names.com. And if you look at the search, if you don't have to go through the whole search, you just have to look at what it is saying, the search title or the title of the web page and the URL itself. So if you say it says Chekuri name meaning, the very fact that it is giving this basically means that Chekuri is a valid name, right? The very fact that you're getting ancestry.com means that there are a lot of people with the same last name and hence they can check their ancestry through ancestry.com. So this is again, if you get results from Ancestry or if you get results from names.com or if these titles have something to do with names, obviously Chekuri is a valid surname. This is a hack. Okay, so this is one strategy that you can employ. Another again, I'm just using Microsoft Bing search API. Another search API that you can do is you can just type just the last name. This is my last name, right? I share a last name with a very famous algorithms professor at University of Illinois called Chandra Chekuri. I'm not related to him personally, but yeah, so I know that he's a professor of algorithms at University of Illinois Urbana-Champaign. So yeah, so the very fact that again this is called a person result. This result in Bing search, basically this block basically means it is a person. So Bing, whenever it recognizes a person with the name, it gives you a person result. Similarly, if you look at related searches, you can get the related searches data also. Look at the related searches. There are a lot of people with Chekuri name. I don't think I know any of them, but yeah. So yeah, so if you see a lot of other people with the same related search, again, this has doctor. I think most of these are doctors at various parts of the world. And there is a person with this name, a very famous person who is a professor of algorithms. Similarly, if you look at this, you get a names.org result, which says, what does name Chekuri mean? So this is also another indication that, again, these are all various signals to you that Chekuri is a valid name. Of course, when you write the final code, you'll have to use all these signals to make an informed rule-based system. You don't have to train some complex machine learning system. You just use Bing search API, get this data and write a very simple rule-based system. Now, another thing for first names, this is something that I have seen because we had a baby a few years back and we were searching left and right for baby names. So another hack that I thought of because of where I am in my life, so my first name is Srikanth, right? So you can type Srikanth name meaning. Then you will get a bunch of websites which talk about what is the meaning of the name Srikanth. Srikanth, I think, if I'm not wrong, is Sri is Lakshmi and Kant means husband. So Srikanth is Lord Vishnu, Lakshmi's husband. So yeah, so another very interesting strategy is if you search for my name along or any valid name with name and meaning, or you can say Srikanth baby names, right? If you search for it and if you're getting some of these baby names, right, or if you're getting these search results which says meaning of, that means this is a valid name, right? So this is a very simple hack that you can build for first names and last names. Here is another, again, I just want to show you that this works for various nationalities and cultures. So I was thinking of a first non-Indian name I heard in my life. When I was a very young kid, probably 7-8-year-old kid, I heard this name called Butros Ghali. This is one of the first non-Indian names I remember from my childhood. This name sounded very funny when I was there. And the reason I learnt about this name was because I believe in news, or my parents told me that he was just elected as a Secretary General for the United Nations. Yeah, it says that he was Secretary General of UN from 92 to 96. This was when I was in from 8 to 12 years, if I'm not wrong. So I heard this name and I said, okay, see, Butros is not an Indian name. So let's assume I search for this name. Again, I misspelled the name intentionally. The Boutros Ghali's name is Boutros, but I typed Botros. But still, you get it autocorrects. That's a beautiful part of search engines. They automatically correct. They recognize that there is a typo here. They give you this name and they also have this meaning of names. This is one way that I can automatically recognize that if somebody enters the name Boutros, I know that it is for sure a valid name. Of course, it's of a different nationality, if I'm not wrong. Boutros Ghali was an Egyptian national who was a Secretary General of UN. So it works across cultures, across nationalities. So this is a hack that we can use. Again, to be honest with you, you can call it a hack or a strategy, but it works fairly well in practice. Cool. So one thing that always keep in mind, I'll come to some computer vision problems in just a couple of minutes, but always remember that the internet, there is super valuable internet data, especially at search engines, Again, for search engines, don't just think search engines of Google or Bing. Every major e-commerce company has a search engine. Every major internet portal has a search engine. Okay, anywhere you see a search bar, whether it is Quora, whether it is Stack Overflow, whether it's Google, whether it's Wikipedia, there is a gold mine sitting there, right? For example, you can use the top results as we have seen in the previous examples. Sometimes spell check or spell correct is also very useful. Some searches, again, to obtain data from search, like Bing gives you API, Google doesn't give you an API. For Google, you have to scrape the data. Unfortunately, earlier Google used to have a web search API. They discontinued it later, right? So right now, if you want to use an API based mechanism, you only have Bing. Rest everything you'll have to scrape in an appropriate manner. Don't just throw thousands of queries every second or every minute. Be responsible when you scrape data, right? So you can also get related searches. For example, if you go to Google here, right? Again, if you want to get data from Google, you have to be fairly careful, right? So for example, I have some of these search results, Boutros Ghali. So, okay, how to delete, okay, so let's assume I ask this question, how to delete Instagram account. So there are also other questions. Okay, these people also ask. This is a very interesting section. So you can ask this question, you can extract this information using a web scraper in a sensible, respecting the robots.txt, and you can get all the related questions. Similarly, if you go down, these are all the related searches that people are making. Look at this. So this is also a gold mine of data. Don't forget that. Anything that you see on a web search result of a web search engine or a e-commerce search engine or any web portal, everything is gold mine. Because they've designed this. Again, if you look at any major web portal, their search engine has a fairly large team. There are hundreds of engineers and scientists who work at the large e-commerce companies, and I'm sure there are thousands of people who work at Google just on search. So whether it's top results, whether it is spell correct, whether it's related searches, whether it is answers, whether it is autocomplete, whether it's people also ask, all these are fair game to extract. So next time when you want to extract data, always think of search results and think of all the things that search engines provide us as data, right? It's super valuable. I have used it in so many projects. We have used it at Applied AI Course. Our students have used it. It's a terrific source of data. So all you need is a problem solving attitude or a jugaad attitude, as we say in Hindi, right? Jugaad is basically trying to find innovative solutions where there aren't many resources, right? Imagine if you don't have data, you're using search engines and other resources. All you need is a problem solving attitude and mindset. You have to have that hacky mindset to solve these problems. Okay. So let's move on to a computer vision problem. Since it's already 8 p.m. We'll spend another 20 to 25 minutes on this computer vision problem. And then we'll do the general Q&A. Okay. So I hope there are no glitches, just to be sure. Okay. Okay. So no hiccups here. Good. Cool. So, okay. So let's take a computer vision problem. Suppose you're working at a company. Again, I've just made up a special case of this. This whole case study is based on some problems that I worked on in computer vision in my own experience. But since I'm not at liberty to discuss the exact problem itself, I will discuss the strategy with another real world example. Okay. So again, something very similar to this is what I have built in my own professional experience at various internet giants. So the computer vision problem is this. Imagine you have a huge repository of images. Let's assume you have some 10,000 images. Okay. Let's say this data set is capital D, right? You have 10,000 images. Oh, sorry, 100,000 images. I'm sorry. This data is completely unlabeled. You're just sitting on images. Again, you can download these images. If you want, you can download these images using APIs. For example, we described this, right? Using Amazon product advertising API, we downloaded information including images of, I think, 180,000 odd products on Amazon fashion, right? Apparel, accessories, etc. We downloaded that using the API. So it's not very hard to get this data. But imagine you're working at a company. Again, what you want is you want to label custom images. Okay, the example I'm taking here is, imagine you're working at a fish factory. Okay, many of you may not know this, but fishing is a huge industry across the world, especially in Europe, also in some parts of India. Suppose you want to determine whether a fish is fish type 1, fish type 2, fish type 3 or fish type 4. Again, I'm not an expert in fish species, but let's assume you have these hundreds of, you're working at a factory which automatically sorts these fish, right? Again, there are a lot of large factories where they catch tons and tons of fish. There is a fish processing center where you have this, you can take photographs of each fish that is passing through on your belt, conveyor belt, and then you have this huge repository of images. Right? Imagine you're working in that. Again, this is a problem that this is not a problem that I worked on, but similar in concept. Okay, so you're given a large unlabeled data set of this fish, 100,000 images, and you know that there are 4 types of fish here: C1, class 1, class 2, class 3, class 4. There are 4 types of fish, 4 species of fish. This whole data is unlabeled and you want to label it. Again, this is a custom data. This is not general data. This is custom data. For example, if it is general objects, right? If you want to label a car, if you want to label a bus, if you want to label whether there is a person here, for this there are already pre-trained convolution neural network models that you can use. But this is custom data that you want. On your data, you have these 4 species of fish. How do you now label these 100,000 images in, let's say, a week or 10 days? Right? Let's assume you want to do this in a week or 10 days, probably with very few human resources, as few human resources as possible. How do you do that? Again, a very similar problem I worked on at Amazon when we were, instead of 100,000 images, we were sitting on millions of images from the internet and from Amazon's own repositories, which we had to label into multiple categories. Cool. Okay, let's take this. So the way we can tackle this is as follows. Okay, so for this problem, to solve this problem, there are 2 components. I will assume that you know the high level of machine learning, very high level, and we'll also use some internet data to solve this problem. Okay, so again, here you will have to use the smarts of machine learning in addition with some additional data from the internet. Again, I'm not saying this is the only solution, but this is one valid solution which can be used, which again some of our students have used in their case studies, in their self case studies, when they don't have high quality labeled data. Right, so let's assume my data set is D. Each image is x1, x2, xn. So this n is 100k now. So we have 100k images. So we take a pre-trained convolutional neural network. Again, if you don't know what it is, don't worry about it. You can just a Python code, you can download a pre-trained convolutional neural network model. You pass each of these images to it, it will give you a vector. Again, those of you who don't know what is a vector, think of vector as an array of fixed size. Right? This is, let's say, an array of 512 floating point numbers. Right? So what this pre-trained, those of you who know machine learning and deep learning, this pre-trained CNN, as you know, it takes an image as an input, it returns this vector 1, which is a representation of image x1. Vector 2 is a representation of image x2, and so on and so forth. And again, the pre-trained convolution neural network need not be trained on anything like your data. It is not trained on your data. It is trained on some 1 million images from the internet. Right? There is a very popular data set called ImageNet, which has a few million images, and it could be trained on it. That's okay. So these vectors are not perfect. Okay. Ideally, we'll come to the ideal part in a while. So what we'll do now is, we will do a Google image search or a Bing image search, right? What we'll do here is, for each, so for example, imagine I have 4 species of fish, right? I have C1, C2, C3, C4, 4 species of fish. So let's assume C1 is, let's take a fish. Okay, I'm not very good at fish, so let me just Google search it myself. Images, okay, so google.com. Okay, so there is something called sea bass. Okay, sea bass, yes. So okay, so there is a species of fish called sea bass. Okay, so imagine you have sea bass, then you can do a Google search or a Bing search. You will get images of lot of types of sea bass, or you can say sea bass India, because I'm sure the sea bass is available in many parts of the world. Of course, let's assume you take the first 100 images, you will have to remove some of the useless images or some of the images which are not very helpful, right? For example, you can just scan through the first 100 images, because you only 4 classes, right? So look at this. Okay, cool, this is good, this is good. Again, you have to be an expert in fish. I'm not an expert, but imagine if I'm working at a fish factory, I'll have domain experts. So I can download some 200 images in this. I might want to cut this image part, right? Or I might want to not use this diagram. I may not want to use this diagram because this is a cooked fish, right? So I can use a few, so using Google image search or Bing image search, I can download, let's say, top 10, or better still, use top 100 images. But when you take the top 100 images, pass it through a manual review, which means you'll show these 100 images to a human expert and say, hey, are these actually class 1 fish, which means are they sea bass or not, right? So you have these 100 images, or 10, let's say, I'll use 10 as an example, but more the better, right? So let's assume you have 10 clean images of sea bass, which is class 1. You pass it through the same pre-trained network, right? So for class 1, you had 10 images, right? For these 10 images, you will create 10 vectors. Remember, all these are 10 vectors. This corresponds to the vector corresponding to the first image of the first result for class 1 fish. This is the vector corresponding to the second image of the class 1 fish, and so on and so forth. So you do it for class 1, you also do it for class 2, class 3, class 4, right? So what you get now is, you get this, okay? So for class 1 fish, let's assume this is sea bass. Let's assume this is some pomfret. I don't know, I think pomfret is a dish, or again, I'm not an expert, but let's assume there are 4 species of fish. So each of this is a vector representation of a valid image from the internet. So we are combining both sources. We are using internet images with manual review, and it can be done, right? Because the manual review, they can do it very, very fast. And I'll show you how manual review can be speeded up using some simple user interface innovation that you can do. I'll show you that in just a couple of minutes, right? Again, because there are 4 species of fish, 400 images, they can do it in like 1 hour. Easily, they can clean up the whole data in less than 1 hour, oftentimes in just 15-20 minutes. Cool. So now what we do here is, look at this. We have these n vectors, right? These n vectors corresponding to the 100,000 fish, or 100,000 images that we have. This is our custom data. This is our custom data. Now these 40, look at this, these 40 vectors are what we have, 10 vectors for each class of fish. Then what we do is something called as nearest neighbors. Again, those of you who know k nearest neighbors, it's a very simple strategy, right? All you do here is you say, for this vector, which of these vectors are nearest to it? Which of these 40 vectors are nearest to this vector? Similarly, for this vector, which of these vectors are nearest? Because proximity or nearness represents similarity in machine learning, right? Suppose if you know basic k nearest neighbor like strategy, all you do here is you take each vector here from our 100k data set, you take each vector here, amongst these 40 images, you look at the top k nearest neighbors. Suppose imagine for V1, let's assume you take the top 5 images or top 5 vectors from this 40, and let's assume 4 of them come from this C1, 1 of them comes from C3. Then you can easily say that V1 most likely is the image of a fish that belongs to class C1, right? So what you get now is, for each of these images, For each of these vectors, again, remember each vector corresponds to an image, x1 to xn. For each of these, you get tentative labels. These are not absolute labels. So we are using a very simple strategy. Again, all this data came from the internet with some manual cleaning, right? Internet data plus cleaning, plus manually cleaned data, right? What you have is tentative labels. They're not perfect data. They're not the cleanest of data. Remember, errors may exist and errors will exist in the labels that you have given using a k nearest neighbor like strategy. Here, there is one more strategy. This is something that I learned from a friend of mine who is a very senior, who is a director level technical professional at an e-commerce giant. So this is something that he taught me. He was a great mentor, great friend of mine. He taught me this strategy because he used a similar strategy at another company, other startup that he worked on. Right? Again, you learn a lot from your peers and people who have more experience than you. People who have been there, done that. Okay. So what he recommended was, okay, so I'll share that idea. So imagine, remember I have 100,000 images. Okay. So let's assume I take, so remember that in the previous step, for every image, I have a tentative label that I have based on the k nearest neighbor strategy. This is a tentative label. This is not the perfect label. There will be errors and we should be able to correct them very fast. So the strategy that I learned is as follows. Let's take class 1. Let's assume class 1 is sea bass. Okay, some species of fish. So you show 100 images on a 10 cross 10 grid. So there will be one image of a fish here, right? There will be another image of a fish here. So just show this 10 cross 10 grid to a human expert. Okay, to a human expert. Again, remember, humans are brilliant at finding odd man outs. Okay, humans are brilliant at this. Even small kids, if you show them some 100 images and say, hey, which of these is odd man out? Which of them do not belong to the set? They'll very easily find it. So what we saw, the way we solved this strategy of labeling it correctly, because what we got was tentative labels. We want to correct those labels. And the strategy we employed is very, very simple. It is, we would create a grid of 100 images. We will show it to a human expert, right? We will show it to a human expert and we'll say, hey, the model thinks that all these 100 images are images of class 1. Do you find anything wrong? So he'll quickly scan this and he'll say, hey, this is not true. 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 That's it. He can scan 100 images very quickly because humans are brilliant in their visual cognition, right? So they can do it very, very fast. In my own experience of building a similar solution with human reviewers, we can process about 100 images in a single shot. And to process these 100 images with some practice in the problems that I worked on in e-commerce, the human expert could do it in 3 to 5 minutes. Actually, significantly less. Even sometimes 1 to 2 minutes also, right? So now if you have to do it for 100k images, you just have to have 100 such grids. And technically speaking, if you have a reasonably sized team of 2 people, 2 manual reviewers who are working 8 to 10 hours a day, you can get this whole 100,000 images labeled in just 3 or 4 man days. So one person working for 1 day is 1 man day, right? So if you build this well, you can, again, this has 3 parts here if you think about it. This has, you're using pre-trained computer vision models, right, to help us. Instead of starting from scratch, we are using pre-trained convolutional neural networks. We are using data from the internet, right? Because data from the internet can help us in getting these nearest neighbors and getting us some tentative labels. Then we are using a simple user interface asking our human experts to find odd man out, which can be done very, very fast. And the problems that I worked on in e-commerce computer vision, we could solve millions of images in just a couple of weeks. Of course, we had a larger team. So this is basically a mixture of, we are doing labeling large amounts of custom data, using internet data to get tentative labels, and then using a very smart and simple user interface to correct these labels very quickly, right? Again, this is a strategy that I personally learned in my own professional experience working at various companies, learning from some phenomenal mentors of my own. Cool. So with this, we have covered some of the most interesting concepts here. So, okay, so let's open up the chat for Q&A. Just give me a second here. Okay, let me try and, okay, so I think I'll have to adjust the webcam. Just give me a second. I turned off the light here. Cool. Cool. So let's get started. I will try to answer the questions. Okay, so let me get into the chat window here. Give me a second, folks. Okay, so since we are open for Q&A, please post your questions. So there is Amazon Product API. So look at this. So you can, okay, so let me start sharing the screen with you. Okay, let me share the screen. So there is something called as Amazon Product Search API, I think. Let me just Google search for it. Yeah, it is there. Yes. So look at this. It's called a Product Advertising API now. Yes. So this is called Product Advertising API. This is part of Amazon Web Services. This still exists, and this is what we used. Again, you can't use it. You can't use APIs for everything. For everything, you may not have APIs available. In such a case, it's best to scrape your own data. Right? Cool. Where are we now? Okay. Just give me a second. Okay. Cool. Okay, did I miss anything, or 1 second? Okay, I'm getting answers for previous questions. Okay, so let me open it on my phone. That's better because it's more up to date. I think my browser window is still updating. Okay, so let me tackle this one by one. What strategy can we use for internal data like IT support tickets to extract aspects for multiple applications when there is no search data or when they are looking at survey data about an event? Interesting. So Neil, what you're saying here is you have some, okay, let me just try to understand this. You have some IT support tickets and you want to extract aspects from this. Okay, that's an interesting point. So one way you can tackle this, again, you can, if you don't have search data yourself internally, one thing that you can do here, I'm just thinking aloud here, like we have our own ticketing system, and from that I'm trying to think through. So what you can do here is you can take all the raw data, try to extract keywords. Again, don't do advanced NLP stuff, just do simple TF-IDF based stuff, get the keywords and look at those keywords which occur more often, and do a grouping of tickets by these keywords. Now what happens is those keywords, again, you need humans in the loop sometimes. You can't completely run away without humans in the loop. So a quick first cut solution that I can think in a couple of minutes is use simple TF-IDF based strategies to extract some important keywords, and you can sort them by frequency, or you can sort them by the TF-IDF score itself, and have a manual reviewer go through these words quickly. That way you can get aspects. That's another strategy to which you can get aspects fairly quickly. Okay, cool. Okay, so I think this is, okay, where am I? I'm a little lost. Okay, so, okay, the flood of questions is very high. Okay. Yes, Santosh, you're right. A lot of people imagine that you don't need humans in the loop. Most large companies have huge human reviewer teams to make it happen. So using Bing API, can we get search results for any query except for objectionable content and adult content? I think you can get it for any search query to the best of my knowledge. What software will you use for search? Again, there is another live session that I pointed you to, right? So you can write all this code in Python itself. If it's Bing, you can use web APIs. If you want to scrape it, you just have to write a very simple get a HTML page, extract the XPath, extract the exact content using something called as a Beautiful Soup, very popular library. So this is a good question from PRKGR. How do you get same image sizes? You don't get same image sizes. You resize them. In OpenCV, it's one line command, right? So you can always resize them. Cool. This is Tanveer has a question, which is software engineer versus data scientist. I think this comparison is unfair. Let me put it this way. Most careers, if you excel in this career, it doesn't matter. I have software engineers who are not data science guys, who don't know what is a logistic regression model, but they're phenomenal software engineers. They can build a cloud-based service, like a proper AWS service, in very quickly. So I have a lot of friends who are world-class software engineers, right? Some of them have their own startups, some of them work at large giants as senior engineers, principal engineers, etc. So at the end of the day, whether you choose software engineering, whether you choose data science, whether you choose machine learning, whatever it is, try for that excellence, because if you are excellent in that field, it really doesn't matter. You'll have ample career opportunities whether you go through the software engineering field or you go through the data science field. So it's not this versus this. It is try to excel whatever you pick. Cool. Raghav has a very good question. This is a question that we often get over email. In case I'm planning to do higher studies, how to choose best universities in AI or machine learning? Again, it depends on which country you're choosing at. Let me talk about India and US, the two largest countries that people pursue their masters in. In India, the simplest thing is look at ratings given by Government of India, the NRIF ratings. They're fairly solid. That's one resource. And look at the professors who work there. In India, it's mostly Indian Institute of Science, the old IITs. There are also some top universities like Tata Institute of Fundamental Research, Chennai Mathematical Institute, ISI Kolkata, a few good IIITs. So all of them have very high NIRF ranking, either in research or in regular undergraduate level education. That's one ranking mechanism that you can use. Again, universities that have a higher ranking there tend to be fairly good in general. Number one. Number two, if you're looking at US, look at the, I think it's US News, if I'm not wrong, right? Which has the yearly ranking for master's or graduate school in computer science. So most schools which have strong computer science departments tend to generally have strong AI and machine learning divisions or faculty and courses. So the general rule of thumb is always look for the top universities that you can crack, that you can get admitted in, and those you can use any of these rankings. Whether in India, NIRF is a very reliable source because it provides rankings of universities in India by Government of India. You can use US News and all of that in the US. Again, this is a general guideline. I'm not saying that this is always true, but it is generally true. So Raviksh has a question. For image search, can we use a VGG pre-trained model? Yes, you can use a VGG pre-trained model. You can use a ResNet. Again, ResNet is more powerful than VGG16, right? You can use any of these pre-trained models, and most of these pre-trained models are available in libraries like TensorFlow, Keras, PyTorch, etc. Cool. So what all things should I focus on higher education now? Okay. So if, again, I think I'm not an expert in higher education abroad, but in general, try to have good grades, try to have strong academic credentials, try to have great projects as part of your undergraduate study, and try to have good scores in your GRE or GMAT or whatever you're using. Those are general guidelines that anybody would give. Again, I'm not an expert in this, so these are general guidelines. This is Hegde. Hegde has a question, which is, if we collect data like images of fishes by ourselves, no need of human loop, right? No, right, Hegde? Because whatever data you have, you still need to label them. Because imagine you collect, suppose you are at a fish processing factory, you have these 100,000 images. How do you label them? If you already have labeled data, then there is no need of human in the loop. But here we are talking about when you don't have humans in the loop. Cool. So Srikanth has a question, which is how to set entities for chatbot data and extract those entities. It's a good question, Srikanth. Chatbots become tricky because of the language. If people use proper English, chatbots work fairly well. The reason being, if the grammatical structure is clean, it's very simple. Again, we have some live sessions on our YouTube channel where we discuss about how to design a chatbot, where we describe some of these challenges. So please check that out. I think it's a 2 or 3 part live series where we discuss this, number one. Number two is, if you want to extract, again, if the sentence is properly formatted, state-of-the-art entity extraction models, which are based on transformer stuff, will work fairly well, right? So they work fairly well. But if you don't have those, you will have to build your own custom data. Like, for example, imagine if your chat data is mostly English, which is a combination of Hindi and English, or if it is Tinglish, which is Telugu and English, then you will have to manually sit and get them labeled. There is no escaping that fact, right? Because you don't get English or Tinglish data with entity extraction on YouTube search or Google search. So Neil says, at a high level, how does image captioning work? Again, there are a lot of highly quality image captioning data sets that you can download from internet. Most of these are designed for research purposes. You can train your models with these, and what you have is basically an encoder-decoder model with encoder encoding all the information in the image, the decoder generating the text for you. And these models work fairly well. Many of our students have used it in their self-case studies. They work fairly well. So can AI design anything? That's an interesting question. This is from an Elias called Mr. Tech. Yes, so AI in architectural design and even manufacturing design, there is something called as automated or AI driven design. So of course, this is mostly used. So Autodesk, which is one of the top companies which makes manufacturing and mechanical engineering design software like AutoCAD, like STAAD, etc. So they have a tool. I forgot the name of the tool. I'll have to Google search it myself, where they can give all the constraints they want. They can say what the machine should do, and the AI system will go ahead and design based on the constraints you give. It might say, hey, I want to use only the weight should be this much, but the strength should be this much, and things like that. So there are tools built by the manufacturing tool makers. Yeah, somebody's saying it's called Fusion 360, is it? Okay, I think Fusion 360 does topology optimization. Am I not right? Again, there was a time, it's called Fusion 360. Okay. Yeah, again, I'm not an expert in this field. I read about this research from Autodesk research. So yeah, I'm sure there are more tools. Autodesk, the only reason I know about Autodesk is because I read a research paper from them maybe a few years back on how they do it, right? Cool. Yeah, it's called generative AI. That's a nice thing. Yes, Shubham, thank you for that term. It's called the generative AI. Yes. Okay. So Syed says, how to get good in building transformers for custom dataset like time series and not just limited to text datasets. Again, transformers are not as much used for time series data because the whole architecture itself is much more well designed for text data. That's what the whole purpose of the design of the architecture is. Right now, there are image-based transformers that are taking shape. In late 2020, they started becoming more popular, but they're not still mainstream. As and when they become mainstream, we'll surely cover it in one of our live sessions for sure. For time series data, still LSTMs are pretty good. Transformers, while you can use them, not very popular and probably not add too much value for you. Ideas to build a web scraper which will scrape prices of all the products across Amazon with frequency equals to every day. That's extremely hard engineering problem. Trust me. It's an extremely hard engineering problem because Amazon will start blocking you because there are like hundreds of millions of products on Amazon. If you try to scrape it from one IP address, it will simply block you, right? So what you have to do, what companies do is, people who scrape this data is they have thousands of computers distributed geographically, some of them distributed across the world, through which they'll keep scraping this data by scraping only a few pages from every web browser. They'll have thousands of accounts, some of them even valid accounts with credit cards. So, I mean, there's a lot of competitive stuff that happens. I'm sure other e-commerce players in the US would scrape Amazon data because they want to get their competitive intelligence. And I know some e-commerce giants which scrape Amazon data daily, but their infrastructure costs millions of dollars. Okay, cool. So Pranav has a question which is AutoML. Again, we have a live session on that on our YouTube channel. We have a dedicated live session on the pros and cons of AutoML, what it can do, what it can't do, what is the hype about. So please check that. It's a detailed 2-hour session. Okay, cool, folks. So the question here is about applied AI course helping students in Canada. Currently, it's not on a roadmap because the number of job openings in Canada is still quite few. Right? It's not as large as India or as large as the US. That's why we are not yet focusing too much on it. So Yugrath has a question. Is becoming a master at databases good? Does databases have a future? Who said no? Imagine all the data that we are collecting. We are sitting on literally zettabytes of data today. All of this has to be stored in some form of database. So when you say database, don't just become good at the classical relational databases. You have to be good at every form of database that sits out there. Whether it's a columnar database, whether it's a document-oriented database. So learn all the NoSQL databases. Even look at how SQL is used in Spark. So don't just stick to Oracle database or MySQL. While they are important, there's no doubt that they're important. If you really want to become a master in databases, become expert at all the major types of databases that are being used today. And like we have had instances where we were hiring at various product-based companies, top senior engineers and even principal engineers who are super duper experts in these databases. There is a tremendous requirement of those people. There is a tremendous need of those people. The problem here is there aren't many people who are really good at that, right? So somebody says FastAI versus TensorFlow, TensorFlow any day. It's just a much more robust, much more wide, more production ready. I can deploy a model on an IoT device. It's just more easy to work on production systems with TensorFlow. Cool. So Bhargavi asks how AI and ML course can help for a big data analyst. Again, if you're already a big data analyst, I'm sure you're working on a few big data technologies yourself. So if you already have that background, transitioning to machine learning and AI seems like a natural thing. Of course, you have to learn a lot more. You have to learn a lot more new things. You have to learn all the mathematics. But as far as the data pre-processing, as far as programming, as far as tackling data, those pieces will be easy for you, right? So we have had engineers, software engineers, or even big data engineers who have transitioned to careers in machine learning data science as a logical transition. So they already know all the big data technologies, and then they learn all machine learning, then they go into the data scientist role. Cool, sounds good. PyTorch or TensorFlow, I think, yeah, so that's a harder call to make. I like both the libraries. Earlier, I was not very much focusing on PyTorch because it was still a very researchy thing. TensorFlow was much more mature. But right now, PyTorch has also become more mature in terms of its production readiness. So you can pick any of them, you won't go wrong. I mean, because I've been using TensorFlow for longer, I'm more of a TensorFlow fan, but it's just a personal choice. You can pick either of them and you won't go wrong. Okay, sounds good. So which one to learn, R or Python? I would strongly recommend Python because it's much more general purpose language than R, right? Cool, sounds good. Okay, I think yeah, we have already spent quite a lot of time. So sounds good, folks. Again, please understand that as a public live session, it's almost impossible for us to answer all the questions that come. Anything that I was not able to answer in this session, or any smart ideas you have, anything, any nice hacks that you could think of, please feel free to reach out to us over email, and we'll try and clarify as many questions as possible. Okay, sounds good. Bye-bye.